afternoon. Who here is from less fortunate, less sunny parts of Europe or outside Europe? Okay, interesting. I think it's worth it to sit here in the dark instead of not being on the beach and everything, so it's fine. Thanks for the invitation again. I'm happy to speak here again. I'm Patrick. I'm going to start with a quote. I've never seen a startup die because it couldn't scale fast enough. I've seen hundreds of startups die because the people refuse to embrace their product. That's from Guy Kawasaki, and it's a great quote to start this talk about scalability. So the topic is going to be creating scalable APIs and API performance. I added that kind of during creating the talk. My name is Patrick. I'm a software architect at Blended. Sorry, there's a writing error on the thing. Anyway, I'm a startup mentor. I work here in Barcelona and also co-organizer of Barcelona JS, Mediterranea JS, and other technology groups here in Barcelona. And first of all, I want to get back to the focus. What is an API? So API means application programming interface, a set of routines, protocols, and tools for building software applications. What does that mean? So an API could send a lot of emails, you could send a lot of notifications, background jobs, heavy computation job. An API never renders content, never renders HTML or something. That's something you don't do. But if any of those things that you do in your API take more than 50 milliseconds to load, you might be on the wrong path, because user experience comes now also to APIs, and that's the whole thing of scalability, to provide a user experience that gives you the data in less than 50 milliseconds or better. So to the topic, where do I start with scalability? Am I talking too fast or too slow or something? Like, raise your hand if it's too fast. Nobody? Okay, great. If it's too fast, raise your hand. Okay. So where do you start with scalability? You start by measuring what is actually going wrong with your API. As an API architect, you take the parts of your API and you start to measure what are you doing, what's happening in your API, and where are you basically, what do you have to do? Because if you can't do anything, you don't know anything if you don't know your numbers. So how do you do that? First thing you start is writing unit tests. That's one of the most basic things in your code. It works on all platforms. I've tried to keep this as most language agnostic as possible. I'm on the Node.js side, so I'm a bit drawn to Node.js and stuff. So forgive me if I do any bad comments about Ruby and Rails or something. Writing unit test means you test your functions, your computational functions, your email functions, and everything that you do in your API on the lowest level. And you have double benefit here. You actually have the benefit of seeing if it works. That's what the test is actually for. But the second benefit is you see what time it takes. Like you can set these tests to show your response time, and to see, okay, they're like 5 milliseconds, 10 milliseconds, and everything is good. And as long as they're green, they're usually a bit under 25 milliseconds. So it's great. If something happens like this year, 1,385 milliseconds, that's something totally unacceptable, and that has to be solved either through performance enhancement or through scalability. So when you have unit tests and when you know what's happening on the lowest level of your API, then you can go one step further and do end-to-end testing. So end-to-end testing means you write your API, you launch your API in a staging server or a testing server, and you have an API consumer on the other side, which actually hits your API with a full HTTP request and see what's going on. On this level, I also test request performance, like on the basic level of HTTP, like what's happening, what's your JSON response, like what does this add to the response time that you can test with a unit test. And again, if it's green, everything is good, but this also tells you if it's like above 25, 50 milliseconds or something, then you should see, mark it on your checklist, like this is something to look into. The third step is response time analytics, or response time and analytics, to figure out that stuff. There's a great tool, it's New Relic. There's nothing to argue about, they're doing a great job. And this is a New Relic dashboard from one of my APIs, and it's actually, there's a lot of information here and a lot of cool stuff that you can see right away also when you have a live performing API, especially that spike here with 100 milliseconds, spiking 100 milliseconds and the throughput going down from 3,000 to almost zero, like something is going on there. You have to look into it immediately. That's one of the good things about New Relic. But you also see a real analysis of your transactions. So you see the tiles and like all your calls, how much time they really need in a live environment. And again, where you can look into when it comes to performance and scalability. And the fourth test that you can do before going live to see if your API actually scales is load testing and stress testing. So I did that recently with first time for one of my APIs. I put 250 concurrent connections on it, and the API went to 2,500 milliseconds response time or more, and it crashed and burned. So that's something I didn't expect, and something like where I was like, okay, that's something to work on. Like 250 concurrent connections isn't that much for Node.js. So where are the bottlenecks? Where can I find out what's going on there, and what can I do to improve that? If you have all those numbers, then you know exactly what's going on in your API. And what do you do then? You measure it again. Like, make sure everything is correct. Run the test 3 times over. Make sure there's no other influences for that test that leads to a wrong result, to actually play a bit detective, make sure you got the right point to attack the first time you're actually thinking about scalability and performance, and then inspect what's going on there, like really to the lowest detail, find out what's going on. After that, we go a bit through Performance 101. Data transfer and optimizing in output. JSON. If you have anything else in the API, just skip it, use JSON. That's the default now, that's the standard. Let's just agree on that. And if you use JSON, like try to minimize transfer data, especially if you have mobile consumers. Don't use excessive attribute names, don't use excessive data objects and stuff like that. Try to keep it simple, try to keep it small. Always think of somebody in a mobile phone, like with a crappy internet connection, like they attack your, like they consume your API, and they have to wait. Like, why do they have to wait? Not because of their network limitations, but because you're sending too much data. And the third point is, write smart response, like smart endpoints. Instead of having the RESTful only API, which just like get, post, put, and all that stuff, try to think about your users. Try to think about your consumers, what they want, what they need in data. So if you have, for example, if you have the Mediterranean API days as an event, like you create an API for that, you get the event, what else could the user require? Do they require a number of attendees, or all the information about attendees? Do they just need the name of the attendees? Is that enough? Do you want the full schedule? What do you need for the schedule? Do you need the speakers? All that stuff matters, and all that stuff can actually influence your performance and scalability by the fact that if you have 100 or 1,000 or 1,000,000 IDs, for example, that you respond in this API. Let's say I only give, like, I do a RESTful call to, like, get me the Mediterranean days, and I only get the event. I was like, okay, I have to go through the API again. I have to get all the attendees. I have to get all the speakers. I have to get the full schedule. That's like a ton of requests that probably like 80 or 90% of your users want, and you're not providing it to them. So all these users, all these 90% of users will basically, they'll go that way. They say, okay, if you don't give me the data, I'll get it. But that means your API is going to be hit like 1,000 times more than just providing the data right away in a lot faster way. Data storage. Try to find the right database for your stuff. MySQL, like, don't hit everything with MySQL. If you have session data, if you have not long-living data and stuff like that, put it in Redis, put it somewhere in a cache or whatever, where it's definitely like faster and processed fast, and also get disposed of if you don't need it any longer. And NoSQL, the whole NoSQL world, like there's pros and cons and whatever. Like try to read a bit up on databases and try to find the right database for what you're doing. MySQL and SQL databases in general aren't the best for everything. That's known by now, but NoSQL isn't the answer to everything as well. So see what's good, and it's actually not bad to have like 2-3 databases in your technology stack. That's totally okay as long as they have a reason to be there. Distance, machine distance, node distance. That's actually a very important thing that sometimes get overlooked. Like if you're creating your cluster in Amazon or something, or Google Cloud, or if you're actually using various servers or various services. So you go for DigitalOcean and get something at DigitalOcean, but then you also get your node services from Nojitsu or from Joyent or something. Those are different data centers. There's a lot of distance between those data centers. Like you will never get a good performance if you have two machines in different data centers. That doesn't work. So if you have like the greatest and fastest database in the world and it stands in China and you're building a startup here, like you have 200, 300 milliseconds response time and you can't do anything about it. So get your stuff together as close to the consumer as possible and as close together as possible. Like try with DigitalOcean, they offer private networking. Amazon, put in the same subnet, Google Engine, like put it together and make sure you're using everything from the same provider, from the same platform provider to make sure everything is as close to as possible. And the fourth step, async it. We're living in an age where you can do stuff asynchronous. You don't have to like go through the whole thing and wait and wait and wait. Like, hey, okay, I'm ready. Go continue. If you're sending, for example, emails, an email takes, like even if you do third-party providers, an email usually takes about a second to send. Like, do I need as a consumer, as your API consumer, do I need to wait that second? Seriously? Like you can respond to that request in 10 milliseconds and just tell the user like, yeah, okay, your email gets sent eventually because my third-party provider guarantees me 99% of the emails will be sent. And if that 1%er comes in and say like, hey, that email hasn't been sent, then just try to figure it out on your side. It's not the consumer's problem, and the consumer shouldn't wait for you to deal with your stuff. Ruby on Rails scaling trick number 1 that I wrote up yesterday, that was hilarious. Cache, 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 and more cache. Seriously, like no way. That's not the answer to scaling, and there's so many better ways to scale systems than just adding caching layers. But for example, request and response optimization is just what I said right now. Like if you have the event, provide more information. Like try to find out what users want. Like don't. Yeah, APIs are getting more important. You're getting more value, more value for your company as well. So think about your users. It's an experience to use an API as much as to use a mobile phone app or a website. It's an experience. So make it a nice experience to your user. Give them the data they want in a single request. Don't let them wait for stuff. Don't let them like call your API like 1,000 times just until they have the data. Give them what they need and try to figure out the middle way. Like, do you have like one user who needs it all and the rest of them, they're happy with what they have? Or is it the other way around? There's just one or like whatever, 20% of the users, for them it's too much data, but for 80% of users, they actually all need that. So try to figure out the way, like what you want to provide, or provide more endpoints to say, okay, it's a 50-50 match, like you have those users and those users. Provide 2 endpoints. Say, okay, this is the endpoint where you get everything, and this is the endpoint where you just get the stuff you need. Figure out what you like. Give them everything they want. Don't let them like suffer with your API. Instagram, great example. They like you don't have to go to the Instagram API every 5 seconds. Like, hey, is there a new picture? 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 No, they send you subscribe to the endpoint. They have a subscription API. And say like, hey, I'm here. Give me something when there's new data. And then they come to you, like one of your friends posts an image, or one of the images in your filter, your search filter, comes up like, hey, there's something new. Instagram comes to you like, hey, you over there, there's something new for you. Come back to your API and get it. So that's how you can make basically an API performing well with a great user experience. Data optimization, that's where the caching comes in. But don't just cache, and cache more, because that will just destroy your whole analytics. It will destroy your whole experience, because if you want real time, if you want to do anything with that, your caching layers will basically be a pain point in your system. Like you get old data, you get stale data, you don't know which of those caching layers is it, like where's the data coming from, why isn't it going to be refreshed and all that stuff. So if you have points where you say, okay, for example, geolocation searches on Elasticsearch, they take time. If the index is big, they take time. So try to think of that. Put in a Redis cache, for example, the same way as Twitter does it. like put a timeline in the cache, in a Redis cache, and let users hit always the cache, like the Redis cache, and just update that every once in a while when there's new data or when there's data to be refreshed, or with a CouchDB update after, like do the requests on Redis, hit Redis as much as you want, and every request, like figure out if there's something new. If there's something new, overwrite it, but let 1,000 requests go through in the meantime. That's how you can basically prevent scaling issues. Components and services. It's 2015. We don't build monolithic applications anymore. So identify the parts of your API. Try to figure out what you're actually doing, what you want to do, what you need to do. So remember what you measured. If you're doing email notification jobs, third-party services, you want data analyzed, you want images analyzed, you want text analysis or something. You're doing background jobs. You're doing actually all these computational jobs by yourself, like you're providing an analytics API. Whatever, if you do cron jobs or anything else that takes 25 milliseconds to respond, so we're actually like setting our goal halfway instead of 50. Think about the microservices. Like identify the components and try to put them into microservices. Nobody wants to wait for something they don't have to wait for. So anything that doesn't require immediate response to the user, like something where it says like, okay, this failed or this was okay. Everything else, just build a microservice. Just put a small service somewhere, saying, okay, there's heavy, pardon? Okay. So there's anything heavy to compute or something, just let that service do it. Example, third-party service to, as I said before, like emails, sending emails, and every time it adds a second to your response, and it's really not necessary. Also, for example, if you do computational jobs, you can actually respond to the user 2.1 or 101 HTTP response codes saying your process is accepted, processing pending. So it's in the queue, it's getting processed, and you can write AJAX requests on the other side, on the consumer side. You can poll and say, okay, either you have two ways again. You can say, okay, subscribe to that task, and I send you an update when it's ready. But in the meantime, you can continue whatever you're doing, or just come back in 5 seconds, and in 10 seconds, and 15 seconds, and I'll tell you when it's ready. Until then, you will always get a 202 processing pending, and once it's done, you're basically getting an update, and you can show a notification on the front end or something like, yeah, this is done, come back and see your results. That's a great way to improve your scalability, performance, because the users can actually continue to do stuff while stuff is processing. Scaling means replacing all components of a car while driving it at 100 miles per hour. That's from Instagram. And the larger your components, the harder they are to replace. So if it's a lot easier to change a tire than a motor. Not on a driving car, but on a car. So think about these components and try to minimize them to the lowest possible thing. Like try to figure out what you can take out of this big API that you're building that you can put into different services and components and let them run separately. Let them run on smaller machines. Like you don't need a lot of hardware to do these jobs. And then you can ask yourself the question, is scaling really your concern? I've built an API and I got this email last week. That is a 1-week report from New Relic. It's an API with 18 million requests per week, 22 milliseconds response time, 0.0005% error rate. So that was my new milestone, 18.8 million, and most of them was actually on a Friday, so it's not just a whole week, it's most of them on one day. 18 million requests, 22 milliseconds response time, 1 API, 1 machine. Like, why should I care about scaling? Like, if I can do 18 million requests more or less in a day, and even if I get like 30 million requests, I add another machine, I add a load balancer, and I have it. So if you do all that stuff, you get a great API that you can scale, and that just like, yeah. Analyzing the pieces that you can scale. APIs all usually follow the same pieces. So you have the database, what you can do with the database. You can cluster it, you can shard it depending on what database you use. Like if you're stuck with MySQL, you're like, okay. But with the NoSQL databases, they offer a lot of parallelization, a lot of clustering options. There is MySQL forks by now which do proper sharding and clustering as well. So find the right database for the job. Find the right web server. Like if it's a proxy, if it's a web server or something, just figure out which is better. Like if you really need to use Apache, everybody knows it's bloody slow software. Like Nginx is faster. If you need a web server at all, if you can just use a proxy, for example, high availability proxy, that thing is insanely fast, and you can do load balancing and all that stuff. Try to figure out your right API platform. Like, do you really need Ruby and Rails for convenience, or can you go to something faster? Everybody knows Node.js is faster. There's no argument about it. So can you do that stuff in Node.js or Python or something else that just gives you more performance that you need? And then, of course, assets. That's just a secondary thing, especially with like bigger APIs where you have to serve assets. Like, put that stuff on a CDN global wide and just don't care about it. There's like, if you put it on a CDN or a S3, you don't have to worry about scaling. You don't have to worry about anything, and it's just global reach. If your users around the world don't care, the users around the world don't care if you wrote your own database. Nobody cares. So and they also don't care what tech you use, as long as the user experience of the API consumer is great. So stay nimble, stay focused with your tools, choose the tools wisely, and don't reinvent the wheel, and you will basically have a highly scalable API that's performing really great right from the beginning, even if it's just one machine. If after all that effort, you still have the need to say, okay, I got to a point I need to scale hardware-wise, then you have the two commonly well-known options. It's vertical scaling and horizontal scaling. So you can add more memory to the machines, which is usually expensive, add more CPU, reboot the machine, everything is good. But double capacity does not mean double speed. So think about it and make sure you really need that, because it's expensive, and as especially startups, you don't want to waste money on that. Horizontal scaling is a lot easier. Just add more nodes. Gives you also the benefit of redundancy. So if one node fails, which happens a lot on Amazon, just you have a second one which takes the job. And you can, like, within a minute, you can add a third one to say, okay, first one is down, second one is up, has all the load, add the third one, and you're good. And that works for all nodes, computation, database, anything. So again, the example like also has you can do cross database, cross data center replication. So if you need to scale from Berlin or from Barcelona to US, just move your data center over there, do cross data center replication, and suddenly you have a good response time in the US as well, or China or wherever. Benefits of horizontal scaling are it's cheaper, it's faster to implement, it adds redundancy and security, but it requires some extra node for load balancing and all that stuff. So have a look at that. And let's do a quick recap. Measure, find the bottleneck, make sure you got the right thing, make sure you find the right piece that needs scaling. If you have all these pieces in microservices, it's super easy. You know exactly, okay, this computation cluster needs more nodes, I can scale it, and I'm back at 100%. If you can fix it with software, that's great. That's the cheapest one. If you have to exchange the component, think about it. Like, usually it's easier to exchange a component early when you're building the platform, because just throwing hardware at the problem will just make it expensive over the long run. So if you can exchange it early, that's great. Exchange it. Don't get too attached to your technology. And throwing hardware is always the last escape in scaling. That's it. Thank you very much. All the stuff will be later. There will be a transcript as an article on blog.blender.io, and the slides will be available after the conference as well.
Yeah, thank you for sharing the slides, and thank you for this content, which is great. We have time for a few questions about scalability. Yeah, one question here.
You mentioned 50 millisecond, and is that median or average or like 90th percentile, 99th percentile?
It should be an average. It should be measured as you say, okay, it's average 50%, because influence, like there are influences which always make it worse than 50 milliseconds or something. And then, you know, like you can actually put alarms on it, say, okay, if the average is higher than 50%, send me an email or send me a notification, say, hey, something is wrong with the API, try to like find the bottleneck, go over again with the measurements and figure out what's going on and try to reduce it.
Hi, great presentation. Question related with asynchronous calls.
Mm-hmm.
Do you have any recommendation to, like, in terms of scaling, how to properly scale, you know, a large or a very large number of asynchronous calls, as opposed to, you know, scaling the incoming, all the incoming requests?
I'm not sure if I understand.
So eventually, if you implement some of what you presented, you end with having to, you know, make a huge number of calls to the outside, informing your consumers that something changed.
Yeah.
Many things can happen, like those machines can be down, they might take too long to respond, and so on and so forth.
That's a quite specific use case. Depends on your server, on your engine. If you use Node.js and stuff, you can always see it's basically not an API anymore because it's actually an actionator. Is that a word? I don't know. So requesting all those machines to send updates and then seeing if they're like, it's basically GitHub and Instagram, they're doing it. They're sending error 500 or something to the user by email, like, hey, your subscription is not valid anymore. So you can do that with HTTP response headers quite quickly. And then if it's millions of requests, you need machines. You need scale vertically. Yeah.
Last question there.
Hi. So could you please tell me what tools did you use for load and performance testing?
For what?
For load and performance testing.
Stress testing. I found, I forgot to add the links there. They're going to be in the blog article. I found one tool which looked kind of new. It's called Loader.io. You sign up, it's free, and you can just use it right away. It looked pretty cool. And there's a bunch of like Linux and Windows tools that you can use from your machines to stress test your API. A Loader, that looked quite decent, and you get the graph and everything, and you can see it right away on the counter side, like New Relic or something, or your dashboard, what's going on. So that was kind of useful.
Okay, thanks.
Thank you very much, Patrick. Thank you.
Thank you.
Applause to Patrick.